Alright, so welcome back guys, and then we want to cover the following topic: the method of undetermined coefficient. That's what we want to cover in this section. So the general solution of a non-homogeneous differential equation is given by the form y is equals to yc plus yp. Take note, the methods of undetermined coefficients work with non-homogeneous equation. So what is a non-homogeneous equation? A non-homogeneous is an equation which has got a g of x which is non-zero term. So if your g of x is not 0, then we have got a non-homogeneous equation. So far we have covered homogeneous equation where the differential equation is equal to 0. Right, so what is your YC? Your YC is the complementary solution and your YP is your particular solution. Right, so your YC it comes from your characteristic equation, and then your YP comes from this method that we're going to cover today, the method of undetermined coefficient. Right, so there are three cases. Like the previous method that we saw, we had three cases. So in this method we have got three cases of g of x. So if g of x is an nth degree polynomial in x, so we assume that the particular solution will be of the form an xn plus an minus 1 xn minus 1 and so on. So if n is equals to 2, so it means that your particular solution will be a2 x squared plus a1 x plus a naught. If your polynomial is of the degree 0, which means that this will be a constant. So your aj's 1 up to n are your constants to be determined. Hence the method is called a method of undetermined coefficients. We want to determine those coefficients. Right, case number 2. Case number 2, if g of x is an exponential function, so if g of x is k e to the ax, where k and alpha are known constants, so we assume that the solution, the particular solution, is equals to b e to ax. So this one does not change. The only thing that changes there is the constant, where b is the constant to be determined. And then the last case is if g of x is given in terms of trig. We're saying k1 sine beta x plus k2 cos beta x, then your constants to be determined will be your a and b. So for a particular solution of a trig form, we substitute by this solution. Right, so let's look at an example. So let's look at this worked example. So find the general solution to the given differential equation y squared minus 2y prime plus y is equals to x squared minus 2. As you can see, your right hand side is not equal to 0. This implies that it's a non-homogeneous equation. So first we solve the left hand side. The left hand side, we solve it using the characteristic equation. So where you've got a derivative, this is the second derivative, we substitute by m squared. This is the first derivative, substitute by m. This is not a derivative, it's just y, substitute by 1. So our characteristic equation is given by m squared minus 2m plus 1, which is equals to 0. If you solve this equation, you will obtain that the solution m is equals to 1 twice. So this is a repeated root. From our previous lessons, we know that if m is repeated, then the complementary solution yc is given by c1 e to the x plus c2 x e to the x. Right, now we have solved for, so this is this complementary solution for the left hand side. How about the right hand side? So the right hand side, this part g of x is given by x squared minus 1, which is a polynomial of degree order 2 or second order degree polynomial. So which means that our particular solution yp will be given by ax, a polynomial of order 2, a2 x squared plus a1 x plus a naught. Right, so what you do now that you have this particular solution, for you to determine these constants, because the constants to be determined in this case are a2, a1 and a naught. So for you to determine these coefficients, you need to differentiate. Differentiating your particular solution, these two will drop to give you 2a2 x, and then this one will give you a1, this one will give you a 0, so this will give you first derivative. Differentiate again this, you will get y prime squared, this one will be 2x. Right, now that you have got the derivatives for y, and then you have got y, you have got the first derivative and the second derivative, it means that you can go to the original equation and substitute for the second derivative, for first derivative, and for y. So if we substitute for this one, we substitute for y prime using 2a2, and substitute for this one using 2a2x plus a1, and we substitute for y using the original assumed particular solution, which is a2 x squared plus a1 x plus a naught, and this is equated to our g of x, where g of x is given by x squared minus 1. Note that I have included this term so that you see that there is a term that we multiplied by 0 there, which is the x term which is not there, so it's simple, multiplied by 0. Right, so if we expand there, this is what we will get. And then collecting like terms, you can see there for x squared we have got a2, for x we have got a1 minus 4a2, and then for the constant we have got this. Then from there we can compare the coefficients. So the coefficient of x squared on your left hand side is a2, and the coefficient of x squared on your right hand side is 1. So this will form equation x2 is equals to 1. The coefficients of x on your left hand side are a minus 1 minus 4 a2, and the coefficient of x this side, right hand side, is equals to 0. So we equate this a1 minus 4a2 to 0, but we know a2 is 1, so we can substitute for a2 by 1, so our a1 is equals to 4. And then lastly, our constant on our left hand side is 2a2 minus 2a1 plus a naught, and our constant on the right hand side is minus 1. So we equate these two to come up with this equation, and then from this equation we substitute for a2 and a1. So a2, remember, it's 1, and a1 it's 4. So if we substitute for this here, so this one will be 2, and then this one will be 8, because it's 4. 4 times 2 is 8. So this is 2 minus 8. This will give us minus 6, taking minus 6 the other side, so this will be plus. So 6 minus 1, so this will give you a1 is 5. So now that you have got your constants a1, a2 and a naught, a2, a1 and a naught, then you can substitute from your particular solution, from your actual particular solution, a2, a1 and a naught. These are the constants to be determined. Then we have managed to determine those constants, and those constants are given by A05, A14, and then A21. Substituting them in this equation, you get your particular solution yp in the form of y squared plus 4x plus 5. Right, now we have got a complementary solution and a particular solution. So the solution is given by the solution of that non-homogeneous differential equation is given by the sum of the complementary solution and the particular solution. So if we add the complementary solution, which is given by this one from the characteristic equation, and then plus the particular solution from the method of undetermined coefficients, which is given by this one. So this will be your final solution to the equation. Right, so those methods, the cases that we talked about, cases which is case 1, case 2, and case 3, can be modified. So these are just examples to show you how we can modify those cases, or we can couple them together and so on. Right, suppose you have got this following example: y prime minus y is equals to x squared e2 3x plus 1. So as you can see, you have got a polynomial there of order 2 multiplying an exponent. So the general solution or the particular solution for this term, it will be a product of a general solution, a particular solution for a polynomial of order 2 and that of an exponent, so to be a product of those two. And then for this one, this is a polynomial of order 0. It's a constant plus a constant, so we add a constant there. That's why we add a constant, say d. You don't want to repeat those constants, otherwise they are not the same and you also create confusion. So try solving this problem using this YP and make sure you practice on how you come up with the generalization and modification. Suppose we have got two cases which are interacting or which have got some linkages. Thank you.